Welcome to GIS2. So today we are going to see how to map land vulnerability assessment using the previous produced thematic layers or thematic geospatial layers. So that we have one, two, proximity to road, proximity to stream or rivers, aspect, land to land cover, rainfall, slope, geology, and elevation. So we have 8 criteria to evaluate land susceptibility assessment or vulnerability assessment of a certain area. In the previous video, we have already see how to prepare these criteria or these thematic layers from different sources and from different data sets that we acquire. So, as I shown you earlier, we have elevation, slope. This categories has been decided. This is land vulnerability or land hazard zonation. So that there is criteria, there is assignments, and these criteria will be used in order to determine the final output of land vulnerability assessment. But how to determine these 8 factors? The sum of these 8 factors must be 100, or the weight of these 8 factors should be 100. So the main idea or the main question behind this calculation is that which one of the criteria gets better weight and which one is comes to second, third, and etc. So this is determined by analytical hierarchical process. In this criteria, there are certain ways we have to determine or we have to assign weights for each. The first one is we have discussed with professionals or stakeholders or a group of experts of the local area to ask and collect such criteria, such weights in order to compare and contrast these criteria, which one did you get the highest value for landslide vulnerability assessment. Then we come to this analytical hierarchical process, multi-criteria decision-making analysis, Excel automatic calculation based on the criteria. So for example, we have this one. As you can see, for example, this is selected participants, this is number of criteria. So in our case, it is 8 criteria. Yes, we have 8 criteria. So the first one is, for example, the first one is proximity to road, proximity to road. Yes, we have to write this one. The second one is proximity to stream, proximity to stream, to stream. The third one is aspect land cover aspect. So the next one is land cover of the study area. Yes. The fifth one is rainfall. The seventh one is slope. Yes. And the final one is the seventh one is elevation. Yes. And number 8 becomes geology of the study area, which plays geology of a study area, which plays a critical role in determining the landslide zonation of a study area. Yes. So we have already assigned such kinds of these criteria. This is comments, we leave it. So this is weight is 19. This is a default weight. So we are going to compare and contrast on this. Yes. For example, we have to compare proximity against others. Proximity to stream, proximity to road. So the other one is 2, 1, 3, 5. This is analytical hierarchy process. One means equal importance. That means two elements contribute equally to the objective. Three, moderate experience and judgment are slightly for one element over. Five, strong importance. Six, very strong importance. That means one element is favored very strongly over another. Its dominance is demonstrated in practice. And the final one is extremely important. This evidence favoring one element over another is of the highest possible order of affirmation. So the intermediate values to that is 2468 can be called used to express intermediate values. So that, for example, let us compare proximity to road or proximity to stream. So select B. Let me give this one 3. Okay, great. B is more important. That means proximity to road or aspect. That is proximity to road. It is good. Proximity to road or land use land cover. So it is land use land cover. Yes, land use land cover is more important. Let me put it 4. Yes, aspect is the position of the land. It contributes its own factors, but in this case, okay, rainfall against roads. Yes, it is rainfall, extremely important. 5. Let me give 5. Not 5. Let me give 2. Yes, a slope or proximity to road. It is a slope. Yes, 1. A slope or elevation. Okay, it's 1 to 1. Geology or road. Okay, okay. Let us put as it is. So we have reached on this. Then we must back to the weights. Aspect or rainfall. It is rainfall. Yes, we have get these weights. Yes, 8%, 18.7. Okay, now let us back to this one. So if we have get this weights, this becomes 100. If I have got this weights, we are going to calculate this one. Go to spatial analysis tools. Yes. Go to overlay. Go to weighted overlay. Yes. Add proximity to road. Okay. Value. Okay. What is the percentage influence? 8%. Let me write this one, 8%. The second one is add another stream proximity. Select on stream proximity. Select on stream proximity. What is the percentage of this stream proximity? 90. Yes. 90. Add another layer. Aspect. Okay. What is the percentage of aspect? 8%. 8%. Land use land cover. Land is land cover. Land is land cover. What is the percentage of land is land cover? 22. 22. Add rainfall. Rainfall 13. So it becomes 13. The slope 7. Geology. Okay. 18. Geology of the study area becomes 18. 18. The last one is elevation. 5. So this is not evaluated perfectly with expert judgments. Simply by judging this on Excel, you have to correctly evaluate on expert judgments. Yes, but this is a typical example how to produce final output of land vulnerability mapping. So just click OK. So weighted overlay analysis has been running. So let us wait the results. This gives us the classification results of landslide vulnerability from multiple thematic layers. Okay, great. So this is what we have produced. Let me uncheck other variables. Okay, great. Let me make zoom to layer. This is landslide vulnerability. Landslide vulnerability. Make sure that all variables have the same resolution, the same projection, and the same cell size so that you can make weighted overlay analysis. So this is high vulnerability, high vulnerability. This is moderately vulnerable, moderately vulnerable. So this is low vulnerability, and this is very low vulnerability, very low vulnerability. Okay, great. So now let us make some amendments. Okay, great. Some changes. Okay, great. Okay. Yes. Okay, great. Now let us make map layout. In order to be a complete map, we have to make a map layout. there are two options in order to make map layout. You can click this one, layout view, yes, or you can click the layout view, the same, yes. Now let us insert some disk map elements. No zero. You can select what you wish, but let me select this one. Let me put here. Let me make some enlargement. Okay, great. Let me insert also scale bars. Scale bars, let me select this one. Okay, let me put here. Okay. This is miles in our case. Let us change into kilometers, or you can continue with miles, it's okay. But if you want to convert or change to kilometers or other units, go to this one, just click km, this is label, okay, so this is how you put, okay, great, insert some mapping elements, okay, scale bar, Norzaro, legend, okay, the legend is disappeared, so let us add finish, okay, this one, go to properties, let us make some amendments on fonts, okay, general, change the fonts what you want. For example, let me select Times New Roman. Yes. 16. Bold. Okay. Okay. Items. Select the styles. Select this one. Okay. Apply. Select the items fonts Times New Roman. Select the size 14 and bold. Okay. Apply. Okay. Great. So this one. Yes. What else? Go to this one, right click, click on properties. In order to add grids, go to grids, select graphics, next, apply. Okay, let us make some amendments. Okay, one, this is the color. Apply. Yes, go to properties again. Lines, not your lines. Okay, apply. Yes, go to again properties, levels, vertical levels, left and right. Yes, font times New Roman. Let us make this one to 10 and bold and apply and OK. OK. Yes. So go to File, go to Export, Land, Slide, Vulnerability map, or map of landslide vulnerability. You can save as PNG, JPG, or PDF, but PNG is the best resolution. Save. This is landslide vulnerability mapping. This one. Very excellent map. Yes. Great. So this is what we have today. You can calculate, you can map landslide vulnerability or hazard zonation with multiple factors using analytical analytic process in accordance with multi-criteria decision-making analysis in GIS and remote sensing by combining. So using these variables, you can produce and map. such kinds of natural disasters for early warning and planning purposes. Thank you for watching.